Hello, and welcome to Technology Spotlight, presented by Murata Electronics in partnership with Science from Scientists. Today, we're going to be taking a closer look at Murata's Soil Water Environment Sensor, an innovative 3-in-1 sensor that monitors soil conditions in several different environments. What does the sensor do? The Soil Water Environment Sensor records 3 different measurements. Soil temperature is a measure of how fast the atoms in the soil are moving and depends on how much or how little sunlight reaches the soil. Soil moisture is a measure of how much water is contained in the pockets between the soil particles. Electrical conductivity measures how much electrical current can pass through the soil and is affected by soil particle size, texture, and chemical composition. So, how exactly does the sensor work? Well, the Soil Water Environment Sensor looks kind of like a big white crayon. This crayon contains a temperature sensor that reads the temperature of the ground. The tip of the crayon contains a grid of 9 extra sensitive electrodes that provide consistent measurements of the soil's electrical conductivity. The electrodes help the sensor measure and compare the volume of pore water, or water in between the soil particles, to the volume of the soil's natural nutrients and added fertilizers. This measurement tells us which elements and chemicals are present in the soil. The back of the crayon is hollow and measures soil moisture. How does it do this? Well, the moisture sensor on our crayon measures electrical permittivity, or the ability of the soil to hold an electrical charge. Within the soil, there are many charged ions, anions, which are negative, and cations, which are positive, that are attracted to each other and create an electrical charge. This electrical charge is determined by the number of ions circulating in the soil. Murata's Soil Water Environment Sensor converts the measured electrical permittivity into volumetric water content, or a measure of how much water is present in the soil. Now, how would a scientist use this sensor? The Soil Water Environment Sensor contains 3 parts: 3 crayon-shaped sensors, a transmitter, and a gateway. A transmitter is an electronic device that produces radio waves with an antenna. A gateway is a hardware device such as a router or firewall that acts as a gate between 2 networks. Each of the 3 crayon sensor tips are planted vertically into holes in the soil at different depths. These sensors are connected by a wire to the transmitter, which collects and stores the data gathered by the sensors. Then, the transmitter sends this data via a frequency-hopping spread spectrum, or Bluetooth, to the nearby gateway. We can then see a readout of this data on a computer or Android smartphone. Fun fact: frequency-hopping spread spectrum, or FHSS, is a secure method of transmitting radio signals by rapidly changing the carrier frequency and is a low-power, low-range alternative to Wi-Fi or Bluetooth. In 1941, famous Hollywood actress Hedy Lamarr, together with George Antheil, co-patented a secret communication system which allowed radio control of torpedoes that could not be easily discovered, deciphered, or jammed. Even though her idea was ahead of its time and not implemented in the US until 1962, after the patent had expired, it is now the basis for modern frequency-hopping spread spectrum wireless communication systems. Today, FHSS is used in many of our day-to-day technologies, like cell phones, satellite communications, and GPS systems. So, who uses this sensor, and what do they use it for? Murata's Soil Water Environment Sensor is a powerful tool that helps scientists understand the growing conditions of their crops. Electrical conductivity is an important measurement for agricultural chemists. They use this sensor to create soil-specific fertilizers. An agricultural engineer would use this sensor to design ultra-high-efficiency, soil-specific irrigation systems. But perhaps the best usage of this sensor is for farmers. The sensor reduces waste and optimizes the growth of fruits and vegetables. Information passed from the sensor to the farmer can help agricultural companies create new formulas and design new equipment to help farmers grow as many crops as possible during the growing season. Thanks for joining us for today's Technology Spotlight presented by Murata Electronics and Science from Scientists. To learn more about Murata and their awesome technology, visit their website. And for more fun at-home STEM activities, check out Science from Scientists at www.sciencefromscientists.org/grow. We'll see you next time.